Good morning, everyone. Let's go ahead and start section 8.2. So this section is on inverse functions, and we're going to find out later that inverse functions graph as mirror images of each other. I guess there isn't a picture in the notes. So you can graph them by, I think I see one. So see this graph here? So an inverse is going to have the exact opposite graph and be a mirror image of it across this line y equals x. So inverses have some special properties. Remember how when we were doing f of g of x and g of f of x, they never came out the same answer. One of them was really hard to get usually, and it came out a big long answer, and one of them was usually easy, and they came out a shorter answer. Well, inverses, when you do f of g of x and g of f of x, they both come out x. So they do come out with the same answer when they're inverses. So this is the notation that we use for inverse. So it doesn't mean it has a negative. You put it under 1 to make the exponent positive. That's just the notation. So that -1 is not an exponent. It's read f inverse of x, or the inverse of f of x. You can say it either way. So sometimes when we want the inverse, we'll actually say the words. Sometimes we'll use the symbol. So you should be able to recognize it either way. If the graph of f of x contains 1 point, since the other one's its opposite, inverse contains a point y, comma, x. So we switch the x and y around, and that's actually the definition of an inverse. How to find it is you interchange the x and y. So going back to this graph, this is on page 8. So see how the point -2, 0 is on the first graph? Well, that means the point 0, -2 is on the second graph. So knowing points on the first graph, I can get points on the inverse graph. So this is f of x. So that point is -2, 0. So this is f of x. So to find the point on the inverse, I do f inverse of x is 0, -2. So that's pretty cool, huh? You just take the points and you flip them around, and that's how we make the inverse function. So if we have a set of ordered pairs and we ask you to find the inverse, so here's f. So this is my f of x here. The inverse, f inverse of x, is going to be the same set notation, but switch each point around. 0, 1, 5, -3, 4, 0. So notice how they're writing the answers, because Connect will be picky about that. They have to be in set notation. They have to have commas in between each point, and, of course, commas between the points themselves, or the coordinates of the point. So the domain of f is 1, -3, 0, but it is the range of f inverse, 1, -3, 0. So the x's of f are the y's of f inverse. That's what this is saying. And the range of f are going to be the domain of f inverse. And that's an important thing coming up. So when we switch x and y's around, of course, the domain of one is going to be the range of the other, and the range of one is going to be the domain of the other. So now our question is, what we're going to use this section to discover is the inverse of a function also a function? So if I find the inverse, is it always going to be a function? So that's what we're going to discover. So we're going to start with defining a one-to-one function. This is pretty important. A one-to-one function is a function that has an inverse. So a necessary condition for a function f to have an inverse is that no two ordered pairs in f can have different x coordinates, and the same y coordinates. A function that satisfies the conditions is called one-to-one. So no two order pairs in F have different x coordinates and the same y coordinates. So what does that mean? This is a better way to write it. Okay, so because I read that and I go, what the heck are they trying to say? So this is me in this box. I made this box to better explain it. So when you were in probably Math 091 or high school, you learned that a function is, if you check all the x coordinates, none of them can repeat, right? So this is a function because all the x's are different. Well, what a one-to-one function says is all the y's must be different too. So 3, 2, -1, 7. So because all the x's are different, that makes it a function. Because all the y's are also different, it's a special function. It's a one-to-one function. So a one-to-one function means it has an inverse, because not all functions have an inverse. And we'll learn about those as the section goes on. But when it's one-to-one, meaning all the x's are different and all the y's are different, that means it's going to have an inverse. So this is what you should pay attention to, not that mumbo jumbo math language up there. Sometimes I think they just try to make it hard for us, because I read that like 3 times and went, what are they trying to say? And then I went, they're just trying to tell you that x and y can't repeat. So that's me in that box. Okay, this one, 1, 4, 7, 5, it is a function because all the x's are different, but it's not one-to-one, which means it doesn't have an inverse because 2 of the y's are the same. So it would pass the vertical line test. All the x's are different. So it's still a function like maybe a parabola, but it's not a one-to-one function. Where this one is a function, and because all the y's are different, it's also one-to-one. So this one has an inverse. And this one does not have an inverse. That's what one-to-one means. So if it's one-to-one, that means I can switch the points and make an inverse. If it's not one-to-one, then I can't. It does not have an inverse. Okay, so last one. 1, 4, 1. Ooh, this one's not even a function. So if it's not a function, there's no way it can be a one-to-one. So you don't even have to test it any further, because in order to be a one-to-one function, it first has to be a function, and functions have every x different. So since the 2 of the x's are the same and they're assigned 2 different y values, that means it's not even a function, so I don't even have to apply the test for it. So this would not pass the vertical line test. So if it's not a function, it can't be a one-to-one function. Okay, let's take a look at this one. So is this one-to-one? So I look at my x's, 2, 3, 4, 6, 0. So it is a function. And it told us it was a function, but we always check anyway, because sometimes they don't tell you. So then I check the y's, 5, 8, 11, -11, 0. And it's a one-to-one function because they're all different. So that means what? That means it has an inverse. So if it's 1 to 1, it has an inverse. That means I can switch all the points around and draw them on the graph. So it has an inverse. Okay, so remember how you use the vertical line test? Hopefully you remember that from your 09 days or high school days. The vertical line test said I could take a graph and draw a vertical line through it, and if the vertical line only intersected it in one point, then it's a function. Well, that's how we test for a function. To test if it's a 1-to-1 function, first it has to pass the vertical line test to be a function. Then it has to pass the horizontal line test to be a 1-to-1 function. This one fails the horizontal line test. So this is a function because it passes the vertical line test, but because it fails the horizontal line test, it's not a 1-to-1 function. But keep in mind, it still is a function. I don't want you to lose track of what you've learned in previous classes. If it passes the vertical line test, it's a function. It's just not a special function. So it's not 1-to-1, which means it does not have an inverse. Okay, and this one passes the the vertical line test, right? I can never pass a vertical line through it more than once. And it also passes the horizontal line test. So horizontal line just hits it in one point. So not only is this a function, it's a 1-to-1 function. So it has an inverse. That's what 1-to-1 means. I just want you to, I'm going to write it every time because I want you to think of these as interchangeable. 1-to-1 function means it has an inverse. Okay, so the vertical line test tells us if it is a function. The horizontal line test tells us if it's a 1-to-1 function, and it has to pass both tests in order to be 1-to-1. It can't just be one or the other. Okay, so let's practice on some. So determine if the graph is a function, then determine if it is 1-to-1. Sorry, I have to have my paper clip. I can't stand my papers falling apart. Okay, so function. Does it pass the vertical line test? Absolutely. So that would be yes. Does it pass the horizontal line test? Yes, it does. So guess what? This is 1-to-1. So if I wanted, let's just do it for practice because this is fun. So if I wanted to make the inverse, I would just look at points. So this is 0, 3.5. So I'd have to go to 3.5, 0. So 0, 3.5. So then go to 3.5, 0. And let's find another point. This point is -2, 6. So 6, -2. So -2. Okay, I should put this in a different color so I don't get these mixed up, huh? So 0, 3.5. So that means this is 3.5, 0. And then this is -2, 6. So this point 6, -2. What is this point? This point's about 2.5, 0. So let's do 0, 2.5.